Hello students, in previous video we have seen the how to determine a slope of transformed line, or if the slope of transformed line is given, how to determine the slope of original line. Also we have seen how to determine the equation of transformed line using the given line and the transformation matrix. Now let's see the transformation of parallel lines. Transformation of parallel lines. Okay, now here actually under any transformation, under any 2x2 transformation matrix, parallel lines are transformed to parallel lines. Parallel lines are transformed to parallel lines. Now let me take one example for showing this. Show that parallel lines are transformed to parallel lines using lines 2x plus 3y equal to 4 minus 4x minus 6y equal to 5 and t equal to 1 minus 1 minus 1 1. Solution. Here two lines are given. Let's check first of all, are they parallel to each other or not. Here let it be L1 is the line, suppose 2x plus 3y equal to 4. This can be written as y equal to minus 2 by 3 x plus 4 by 3. So this gives the slope of this line. Let it be m1. m1 is how much? Minus 2 by 3, right? Similarly, L2 is another line, minus 4x minus 6y equal to what? 5. This also gives y equal to minus 2 by 3x minus 5 by 6. That is m2 is equal to minus 2 by 3. Now you know the property that if the slopes are equal, then the lines are parallel to each other. So therefore what can we say? L1 parallel to L2, right? This is with us. Now we have to check under this transformation matrix, L1 will transform to new line L1 star and L2 will transform to new line L2 star. Are they parallel or not? So for that I can use a result for finding the slopes of L1 and L1 star and L2 star also. I have a slope of L1 and the transformation matrix. I can determine easily M1 star, that is the slope of L1 star. Okay, so here T is what? 1 minus 1 minus 1 1. That is ABCD. That gives A is equal to 1, B is equal to minus 1, C is equal to minus 1 and D is equal to what? 1. So let me use that result. A simple way to prove this: the slopes are equal, then the lines are parallel. Okay, if the slopes of this a transformed line of L1, that is L1 star, and transformed line of L2, that is L2 star. If the slopes of them are equal, then we can say transformed line are also parallel to each other. So slope of L1 star, that is suppose M1 star. What is the result for that? B plus D M1 upon A plus C M1. So this gives, this is our M1 and ABCD are here. So that is minus 1 plus 1 into minus 2 by 3 upon 1 plus minus 1 into minus 2 by 3. That is equal to what? Minus 1 minus 2 by 3 upon 1 plus 2 by 3. And that is nothing but how much? Minus 1. Again, slope of L2 star. Slope of L2 star is what? M2 star. That is B plus DM2 upon A plus CM2. That is nothing but again minus 1 plus 1 into minus 2 by 3 upon 1 plus minus 1 into minus 2 by 3. That is again minus 1 minus 2 by 3 upon 1 plus 2 by 3. And that is also what? Minus 1. Look at here, these slopes are what? Equal. So we can easily say that therefore L1 star is parallel to what? L2 star. So if L1 parallel to L2, that the transform line are also what? Parallel to each other. Okay. So here we should note that parallel lines are always transformed to parallel lines. Okay. Now transformation of intersecting lines. In two-dimensional system, either the lines are parallel or they are intersecting, right? So now here the theorem: if a 2 by 2 transformation matrix is applied on a pair of intersecting lines, then they are transformed to a pair of intersecting lines. They are transformed to a pair of intersecting lines. Okay. So here parallel lines are transformed to parallel lines, intersecting lines are transformed to intersecting lines. Now here the note, suppose we have, let L1 is the line y is equal to m1x plus c1 will transform to L1 star, that is m1 star x star plus c1 star. Okay. And another line L2, suppose y equal to m2x plus c2, that transform to, suppose L2 star, that is m2 star x star y star obviously here also y star, right, plus C2 star as such. Suppose these are transformed to these one. Okay, now obviously after transformation here m1 star c1 star m2 star c2 star has the result. We can get that one using the equation of transform line, but also we can find out the point of intersection of these two lines also. What does that? Therefore the point of intersection of L1 star and L2 star is, it is x star. That x star is nothing but having the coordinates c1 star minus c2 star upon m2 star minus m1 star, and c1 star m2 star minus c2 star m1 star upon m2 star minus m1 star. These are the coordinates of point of intersection of L1 star and L2 star. Now if T is the matrix ABCD under which this transformation occur, then this x star can be written as, then x star can be given as such also. It will be A into C1 minus C2 plus C into C1M2 minus C2M1 upon M2 minus M1, and B into C1 minus C2 plus B into C1M2 minus C2M1 upon M2 minus M1. These are the coordinates in terms of ABCD, and you know the given lines are L1, L2, so we can easily use M1, M2, C1, C2 from here. Okay, so this is the point of intersection of the transformed lines. Now let me take a small example on this. Example: find point of intersection of transformed lines where initial lines are x plus 2y equal to 2, x minus y equal to 4, and T is this matrix 2 minus 1 minus 2 1. Okay, in this question the point of intersection of transformed line is asked to us. The original lines are given this, and using this transformation matrix, or this transformation matrix is applied on these lines as such, it is said in a question. Solution: original lines are, now let first one will be L1, x plus 2y equal to 2, and L2, that is what, x minus y equal to what, 4. Okay, now point of intersection of these L1, L2 if we have to determine, then it is nothing but the it will be the simplification, solving them simultaneously and get the x and y. Okay, so point of intersection of L1 and L2 is, I got that as point P. Suppose it will be 10 by 3 and minus 2 by 3. We have to solve them. Consider it as equation number 1, equation number 2. Either add or subtract and get x and y. Whatever are they, nothing but these coordinates. Okay. Therefore, now you know every point of L1 will transform to new line, and every point of L2 also transform to new line, right? This point of intersection also transform to the new line. This point is on both the lines, right? So the point of intersection of new line is also on both the lines. Okay, so that can be obtained here very easily. No need to use the result and all here. It's a simple thing. The transformed point of intersection is, it will be P star. It is nothing but P into what? T. So P is 10 by 3 minus 2 by 3, and T is what? 2 minus 1 minus 2, 1. So that gives us, the simplification is 8 minus 4. Therefore here the point of intersection of transformed lines is what? 8 minus 4. Having the position vector 8 minus 4, that is what? P star. Okay. Next point is that angle between two lines. Under any 2 by 2 transformation, angle between two lines is not reserved. Means angle is not necessary same. If L1, L2 are two lines, are transformed to lines L1 star, L2 star, the angle between L1, L2 will be theta. Then not necessary the angle between L1 star and L2 star is also theta. It is not required. So let's write few note here. 1. If L1, L2 are two lines and the angle between L1 and L2 is theta, L1, L2 are transformed using any 2 by 2 transformation matrix T A B C D Then angle between transformed lines L1 star L2 star may not be theta. It may not be theta. Second note, under any 2 by 2 transformation matrix, perpendicular lines may not be transformed to perpendicular lines. Third, a rectangle or square is transformed to a parallelogram. One more thing, parallel lines are transformed to parallel lines then parallelogram is transformed to a parallelogram. Okay, now let's take an example to prove this. The perpendicular lines may not be transformed to perpendicular lines. Then this one also through rectangle and square is not it will transform to parallelogram. Okay, so example, show that perpendicular lines are not transformed to perpendicular lines. Using line segments AB and CD, where A having a position vector 1, 5, B having a position vector 1 by 2, 4, C is 2 minus 6, D is 2 by 3 minus 16 by 3, and T is 2, 1 by 2, minus 3 by 2 and minus 3. Okay, now two lines are perpendicular if product of their slopes is what? -1. Let's use that simple trick. First of all, let's find out the slopes of these original lines. Then using this transformation matrix, let's obtain the slopes of transformed lines and check the product of them is -1 or not. So, solution. Consider line AB. A is what? 1, 5. And B is what? 1/2, 4. Right? Therefore, slope of AB equal to M1, that is 4 minus 5 upon half minus 1. So it will be -1 upon minus half, and that is nothing but plus 2, right? It will be plus 2. And line CD, wait, C is what? 2 minus 6, and D having a position vector 2/3 minus 16/3, right? Therefore, slope of CD equal to, let it be M2, right? M2, that is what? Minus 16/3 minus of -6, right? Upon 2/3 minus 2. So it is 2/3 upon minus 4/3. So that will be minus half. Okay. Now here M1 into M2, that is 2 into minus half is what? -1. Therefore, lines AB and CD are what? Perpendicular. Are perpendicular. Now, slope of, but now T with us, T is what? This 2, 1/2, minus 3/2 and minus 3, right? So compare with ABCD, gives A is 2, B is half, C is minus 3/2 and D is what? -3. Okay. So here, therefore, slope of A star B star, that is M1 star, that slope will be B plus D M1 A plus C M1. So it is equal to half plus -3 into 2 upon 2 plus -3/2 into 2, and that is nothing but, simplifying it, you will get it is 11/2. Again, slope of C star D star, let it be M2 star, it will be B plus DM2 upon A plus CM2. So it is 1/2 plus -3 into minus half upon 2 plus minus 3 by 2 into minus half. And simplifying it, we get it is 8 by 11. Now, here, what about m1 star product with m2 star? So, it is 11 by 2 into 8 by 11. So, that is nothing but 4. It is not equal to what? Minus 1. Therefore, I can say A star, B star and C star, D star are not perpendicular. So, angle between two lines is 90 degree, but after transformation it won't be 90 degree. So, perpendicular lines are not necessary to transform to perpendicular line. This is a proof for this. Okay. Next example. Show that angle between two lines is not preserved under any 2 by 2 transformation matrix using line segments AB and CD, where A having a position vector -1, -1, B having a position vector 3, 5 by 3, C having a position vector -12, 3 by 2, D having a position vector 3, -2, and T is -2, 1, 1, 3. Solution. Again, here we have to show the angle between two lines, original two lines, and the angle between transformed lines are not same. It's not preserved, right? So let's find out it. Line AB with A is what? -1, -1. B is 3, 5 by 3. Therefore, slope of line AB, let it be m1, it is 5 by 3 minus of -1 upon 3 minus of -1, and simplifying it, we get it is 2 by 3. And slope of line CD, let it be m2. Line CD, where C and D are given in question, that is what? That will be -2 minus of -3 by 2 upon 3 minus of -half, and simplifying we get it is -1. Okay, here C having the position vector -1 by 2, 3 by 2, and D having a position vector 3 minus 2. Okay, fine. Now, angle between AB and CD is, it will be tan theta equal to m1 minus m2 upon 1 plus m1 m2. Right? So this is 2 by 3 minus of minus 1 upon 1 plus 2 by 3 into minus 1. That is 5 by 3 upon 1 by 3. That will be what? 5. Therefore, theta equal to what? Tan inverse of 5. And that is 78 degree 41 minutes. Okay, it is near about to that one. Fine. Now, t with us. What is t? It is minus 2, 1, 1, 3. Compare with ABCD. That gives A equal to minus 2, B is equal to 1, C is equal to 1 and D is equal to what? 3. Okay. Therefore, slope of A star B star transform line, right? That will be M1 star. That is B plus D M1 upon A plus C M1. That is equal to 1 plus 3 into 2 by 3 upon minus 2 plus 1 into 2 by 3. Simplifying it, we get it is minus 9 by 4. Again, slope of C star D star is M2 star. That is B plus D M2 upon A plus C M2. That is equal to 1 plus 3 into minus 1 upon minus 2 plus 1 into minus 1. Simplifying it, we get it is 2 by 3. Therefore, angle between A star B star and C star D star is tan of theta star equal to M1 star minus M2 star upon 1 plus M1 star M2 star. It is minus 9 by 4 minus 2 by 3 upon 1 plus minus 9 by 4 2 by 3. Simplifying it, we get it is 35 by 6. Therefore, theta star is equal to tan inverse of 35 by 6 and that is 80 degree and 16 minutes. It is not equal to whom? Theta. Look at here, theta. Theta is 78 degree 41 minutes. And here theta star is this. Therefore, thus angle between two lines is not preserved. Okay, so here we will stop. In next video we will see combined transformation and other topics. Thank you.